So we're back and we're going to do some hand tracing. All hand tracing means is to walk through the loop and do what's true, execute the control structures, see what prints after the loop finishes. So once the loop ends, it says when the loop terminates, when it's finished, what's going to print. Well, at the side here, I have the answers for each one. We're going to do a couple of them. The reason I put the answer there is so you could see where we're heading, but the answer itself is not that important. What's important is the hand tracing. So we got to just go ahead and hand trace. So we're going to do example 13. Now, the way I'm going to do this is I'm going to keep track of the variables. So we have a count who starts off as 1, right? I'm going to use C for count. So C is currently 1. And then we go to the loop and P starts off at 0. So P is currently 0. Okay, so what happens here? It says, is 0 less than 5? It's true. So it comes into the loop and it goes, if that 0 mod 2 is equal to 0. Well, 0 divided by 2 is 0 remainder 0. That's true. The counter goes up by 1. I'm keeping track. So the counter now goes to 2. Right? So we're keeping track of all these. Then what happens is that this else doesn't run because it's a double selection. If this runs, this is the not, so it won't run. We come back and P goes up by 1. It's keeping track. So P is now 1. Okay, how come? Because it was 0, gone up by 1. Is 1 mod to 0? No, it's not. Alright, so count needs to add 2. Well, count was 2, so if we add 2 on, count is now 4. P is 1. We get to the end, we come back. P goes up by 1. P is now 2. We come in here and it says, is 2 mod 2 0? It is. So count goes up by 1. Well, count was 4, so count becomes 5. We're coming back because we're in a loop. So P goes up by 1. P is now 3. Is 3 less than 5? Yes, it is. Is 3 mod 2 0? No, it's not. So count goes up by 2. So count is now 7. So P, coming back again, P goes up by 1. P is now 4. Is 4 less than 5? Sure is. 4 mod 2, is that 0? Yes, it is. Count goes up by 1. Well, count was 7, count becomes 8. It's not over yet. I know you're looking at the answer as 8. It's not over yet. Always go all the way to the end, okay? So count is now 8. The else doesn't run. P goes up by 1. P is now 5. The question we're going to ask now, is it 5 is less than 5? No. Stop. Loop terminates when P gets to 5. Count ends at 8. It prints 8. Next one. So we're going to just go through these and knock them out. As a matter of fact, let me go ahead and actually run this. Let me go ahead and run this so we can see 8. The very last thing to print should be an 8, and there it is. So we are correct. Number 14. So here we have a bunch of variables. We got P starting off at 111, Q at 74, REM is 1, and K 0. This is a lot to keep track of, so we'll have to take our time and hand trace this. So here we go. Is it true that rem is not equal to 0? Yes, it is true, because that's 1. So we come in. Rem becomes P mod Q. Let's make a little note here. P mod Q. So this will be 111 mod 74. And that gives us 37. So once this rem becomes 37, we go here and it says, is 37 0? No, it's not. We jump to the else. P is about to change. So P is going to become what Q is, 74. Q also changes, right? Q is going to become what rem is. Q is going to become 37. Okay, we get to the end, we come back. It's a loop. Is rem not equal to 0? That's true because rem is 37. We come here and we perform this again. So let's write the second one. Rem becomes P mod Q. So we got to remember what P is now. P is now 74. 74 mod 37. And that's 0. Well, since the rem becomes 0, the if statement is going to run. Is it true that rem is 0? It is. So K changes now. So K is going to become what Q is. So let's go and check back. Q is now 37. Okay, 37. So all right. So Q is 37. K becomes 37. The else does not run. It's not over yet. We come back. Is 0 not equal to 0? Because remember, rem is 0. False. So we stop. K is 37. That's what prints. Next question. Number 15. Okay. I'm going to run that so we could see this 37. We're going to see the 18, but that's okay. So remember, we had an 8. And now we have the 37. The 18 prints. So let's go ahead and walk through how we get 18. A little tougher here. This is a nested loop. How do I know? A loop inside a loop. So here we go. First, x is 4. Is 4 less than 5? Absolutely. We come into the loop and y becomes 1. The next question to ask is 1 less than 5? Because that's y. The answer is yes. Okay, variables are about to change now. The y value is going to go up by 1. So it's now 2 because it was 1. The x value is about to change. X is going to become whatever x is plus y. So what x is? X was a 4, remember? So because it was a 4, it adds the y on, which is currently a 2. So x becomes 7. Not a 7, a 6. Right? X was 4, y is 2. We add on the 2 to the 4, and we get a 6. All right, we're inside this loop now. Let's not pay attention to this guy out here quite yet. When we reach here, we're coming back here, and we ask, is 2 less than 5? Because remember, y is now 2. And that says yes, so the y changes. Y now becomes 3. How so? Because we add 1. Now the x changes as well. X now become whatever y is, but whatever x is. So x was 6 before, it's 3, so x is now 9. Okay, we're still in this inner loop. We didn't get back out yet. So we come back. Is 3 less than 5? Sure is. Y goes up by 1, then y becomes a 4. X becomes a 13. If you don't know how I got 13, 4 plus 9. Whatever y is now plus whatever x is now, assign it back. Y is 4. Come back. Is 4 less than 5? Sure is. Y becomes 5. Alright, so that means x becomes 18. I know we're at the answer, but don't jump to conclusions yet. We're not done, because when you're in a nested loop, both loops must stop. So let's come back out. Is it true that 5 is less than 5? Why am I saying 5? Because y is 5. Is 5 less than 5? No. This loop just stopped. But that doesn't mean this one stopped. We got to check it. We get out this loop, we know here, we hit this one, we come back. It says it's 18 less than 5. That also is true. So we finally stop. Solution is 18. That's why we printed that 18. All right, we move on to 16. And let's see if we can walk through this one. Now, this one's a little weird because you can tell that the code looks a little mumbo-jumbo. Now, if this doesn't work for you, you can put your curly braces in, okay? So what that means is you put a curly brace around that loop, and you put a curly brace around this loop, So you make it look nicer for you if you want. Okay, I'm not going to do that. So why is that possible? Why is it I could not do that? Well, because this loop has one statement which happens to be a for loop, and this has one statement which happens to be an increment. That's all. All right, so n is 5 and temp is 0. So the first time it starts off, p is 1, okay, and n is 5. So it says, is 1 less than 5? It is. So it enters the second loop. And then q starts off at 0. Now, one of the good ways to actually write this out is to actually think of a point, p, q. Because this, when you nest two loops, this is known as a two-dimensional structure. P on the outside would act as if it were x, and the q on the inside acts as if it's a y. So we get a point, like a coordinate point. So when we're doing this, then let's go ahead and try to write these points. So the first time p was 1 and q was 0. And we got to look to see what happens, because remember, 1 was less than 5, less than or equal to, and 0 is what q is. And then we got to ask the question, is 0 less than or equal to 5 over 2? Be really careful here. This is an integer division, okay? I know, it's how all these little things come back. Integer division, so 5 divided by 2 is actually 2, not 2.5, because it's not a double, it's an int. So this is 2. So is 0 less than 2? Yes. So temp goes up by 1. Temp will now be 1. Okay. The q goes up by 1 now. Q plus plus. So q goes up by 1, but remember it was pq, so q was 0. So now we're at the point 1, 1. Why 1, 1? Because p is still 1. P didn't change. Q changed though. Q is now 1, 1. So 1, 1 comes back and it says, is 1 less than 2? Sure is. So temp goes up by 1. Temp is now 2. See how I'm doing this? This is me walking through all the different combinations. All right, q goes up by 1. Q does go up by 1. Q now becomes 2. So now we're at the point 1, 2. And temp goes up by 1. Why? Because 2 is less than or equal to 2. Okay. The next point that happens is 1, 3. Well, once we get to 1, 3, they come back and ask, is 3 less than 2? No, it's not. So nothing happens here. It breaks the inner loop. This loop escapes. We're done with this loop. Now we come back out. Okay, since we came back out, we are now looking for the guy with p. P goes up by 1. Okay, keep track. So p goes up by 1. P is now 2. Q goes back to 0. So now we have the point 2, 0. Is 0 less than 2? Yes, it is. Temp goes up by 1. Temp is now 4. So I'm walking through this. All right, so that means Q now goes up by 1. So now we're at the point 2, 1. And temp is going to go up by 1. How do I know that? Because the Q value is less than 2. 1. So every time that happens, the temp goes up by 1. Now, we got, so this code then is literally looking for when the y value is less than or equal to 2. If you think of these as points, okay, when the y value is either less than or equal to 2, the temp goes up by 1. Okay, so all we got to do then is find all the points. So we have the 2, 1 when q was 1. So the next point would be 2, 2, because q goes up by 1 again. So when that happens, we say is 2 less than 2? It is. So temp goes up by 1 again. Let's keep going. So now we have 2, 2. We get to the point 2, 3, because q goes up by 1. Is 3 less than 2? No. So this does not print. Or I shouldn't say print. Should not change the temp. So because that did not happen, then we need to go back up to the P. See how confusing this is? Now that's the reason why I said when you're nesting, go at most too deep. This is confusing because it's a two-dimensional structure, and so we have to keep track of two things. So now P goes up by 1. So P was 1, 2 recently. So now it goes up by 1. It's now 3, but Q goes back to 0 right here. Start over again. And temp's going to go up by 1. And if you're following, you could see the easy thing here. So I put a 1 here, but temp went up by 1, so it's 7. And this is 8. You could see how this is going, because all we need to check then is this thing less than or equal to 2. So let's write out all the points. Next one is 3, 2. The temp's going to go up by 1. And the next one is 3, 3. Well, what happens to 3, 3? Well, this is not less than or equal to 2, so nothing happens. It breaks the inner loop. We come back out, P goes up by 1. P was 3, it's now 4. So it's going to be 4, 0. Temp's going to go up by 1. We're now at 10. The next point is 4, 1. After a while, you pick up the pattern. Temp goes up by 1, so temp is now 11. Then it's 4, 2. Temp's going to go up by 1. Temp is now 12. We keep going. And it's 4, 3. Oops, 4, 3. Nothing's going to happen here, because when it gets to 3, 3 is not less than or equal to 2. Breaks the inner loop. Right? So you could see what's going on there. Eventually you pick up a pattern with these things, and if you're not picking up a pattern, you need to look a little closer. So here P goes up by 1 now. P was just 4, so now P is 5, but Q goes back to 0. Question is, would this run? We got to check. It does run. Is it true that 5 is less than or equal to 5? Definitely true. Come in and we start all over. Temp goes up by 1. Temp is now 13. The next point to come along is 5, 1. And temp's going to go up by 1. Temp is now 14. And then the next point, if you're watching, next point is 5, 2. And temp is going to go up by 1. Temp is now 15. I know you're seeing the answer and saying, oh, it's over now. It's not over. Make sure you go all the way through. All right, temp's going to go up by 1 after that. What's going to happen is Q goes up by 1. So temp went up by 1 to 15. Now the Q goes up by 1 to 3. And it keeps, every time we get to 3, it stops the inner loop. It stops the inner loop, but then we have to go back. P goes up by 1, okay? So P goes up by 1. So now we're at 6. Okay, let me don't write it like that. Let's write P goes up to 6. We got to make sure both say no. We have to stop both loops. So that stops the inner loop. 6 stops the outer loop, because 6 is not less than or equal to 5. Remember, n was 5. So once we get both stopping, we're finally done. And then it prints 15. Let's run that and check that out. The last one down here should be 15. One thing with these is that you have to be really patient. You have to go through them carefully. No need to rush. Please don't rush. Take your time and look through and see if you're able to walk through these. So here we go. We got the next one here. N is now 6. Okay, N is now 6. But P is less than N here, and Q is less than N minus P. That's a little tricky. So we got to make sure we pay attention to this, because this is going to change based on N and P. So it's literally 6 minus whatever P is, okay? So let's just check. Temp starts off as 0. So when P is 1 less than 6? Yes. So it comes in, we get 1, 0, okay? And we're going to stop at when 6 minus 1. So we're stopping at 5 here, okay? Temp's going to go up 1 every single time. So let's do this again. So we have the point 1, 0. Okay, P is 1, and it's true, it's less than 6. Q is 0, and it's true, Q, which is 0 right now, is less than 6 minus 1, right? So that's true. So temp, I'm going to use T for temp. Temp's going to go up by 1. Q goes up by 1. So we're at the point now 1, 1. So when Q goes up by 1, we got to check to see, is 1 less than, we got to keep this in mind, okay? P is now 1, so this is going to be a 5 right here. So 1 is less than 5, T goes up by 1, T is 2. Next time we're at the point 1, 2. So we're looking for less than 5 here, so that's true, T goes up by 1. We're at 1, 3. T goes up by 1. We're at 1, 4. T goes up by 1. So basically, everything that's less than 5 makes this thing go up by 1. Okay. 1, 5. Oops, 1, 5. Stops the inner loop. Stops the inner loop, but doesn't stop the outer loop. We got to come back up. And P now goes up by 1. So I'm going to go ahead now and say, well, P was once 1, now P is 2. And guess what Q does? It goes back to 0. And T goes up by 1. So let's erase this because this one stopped the inner loop. And T goes up by 1. And if you're paying attention, you should know that the next one is 2, 1. And T goes up by 1. And the next one is 2, 2. And T goes up by 1. Let's just check to make sure, because we got to make sure we're doing this n minus p thing. So let's see. P is now 2. Okay. And n is 6. So when we do 6 minus 2, we're looking at this as 4. Okay. The first time we looked at it as 5. So we're looking at it as 4 now. So what happens here then is when that thing gets to 4, it's over. So right now we're at 2. So we got to keep going. It's 2, 3. And T goes up by 1. And then it does get to it, okay? It gets to 2, 4. And then it says is 4 less than 4. How am I getting 4? Because P right now is the first guy. In this complete row here, P is 2. And N is 6. So when we do 6 minus 2, we get 4. 4 is not less than 4. So this stops the inner loop. At this point, you start seeing a triangle. Okay? It's getting smaller. Okay? This is like 1, 2, 3, 4, 5 things. 1, 2, 3, 4. And guess what the next one's going to be? 3 things. P goes up by 1. P was 2. So now we're at 3. Q goes back to 0. That works. So T goes up by 1. T is now 10. And then Q goes up by 1. That works. T is now 11. Okay, so how do I know that works? Well, this is 6. Currently P is 3. 6 minus 3 is 3. So we're going to go until we get to 3. Okay, next one is 3, 2. T goes up by 1. And then the next one is 3, 3. Okay. Well, that one doesn't work because at this point, 3 is not less than 3, stops the inner loop. We go again. Since we hit the end of this loop, we're coming back to this loop. P goes up by 1. P now goes to 4. Q goes to 0. Back to 0 right here. Now we're going to 6 minus 4, which is 2. T goes up by 1. So next one is 4, 1. T goes up by 1. The next one is 4, 2. Does that work? Let's check. 6 minus 4 is 2. Is 2 less than 2? No. No go. Not done. We finish with this loop. Come back. P goes up by 1. P now goes to 5. Right? T goes up by 1. How do I know T goes up by 1? How do I know that? I know that because if this is 5, 0, P is 5, Q is 0, is 0 less than 6 minus 5, right? Because P is 5, which is a 1. And 0 definitely is, so that goes up by 1. The next point is the point 5, 1. Does that work? I'll keep writing the 9, so 5, 1. Does that work? Well, that does not work because 6 minus 5 is 1. And 1 is not less than 1. Remember, it's PQ. This is Q here. 1 is not less than 1, so this stops the inner loop. Don't stop yet. Make sure both stop. It comes back. P goes up by 1. So P is now 6. Is 6 less than 6? No. So since the inner loop stops and the outer loop stop, the whole structure stops, and we end with 15. Okay, so I could go ahead and run that again. The last guy should be 15. We'll do 18. So 18 is a little bit different because the print is inside the loop. Okay, so what we want to make sure is we're keeping track of P and Q, just like we did up here. And we're going to walk through this just what we did up here. I'm not going to write any of these things down because at this point you should be able to follow. P is 1. Is 1 less than 6? Yes, Q goes to 1. Right now we're at the point 1, 1. P is 1, Q is 1. First question, is 1 less than 6? We're speaking of Q. Yes. Add the two things together and put them in Q. Right now it's 1, 1, so Q is 2. Add 1 to P. P is 1, P is 2. It prints 2, 2. Right here. They're both 2 right now. We're in the inner loop here. It comes back. It says, is Q less than 6, which is 2? That's true. Come in. Add the two things up. Q is now 4. Add 1 to P. P is now 3. P was 2. Keep track. Print them. We get 3, 4. Since Q is 4, when we come back, is 4 less than 6? Yes. Add the two things together and store them in Q. 4 and 3 adds up to 7. Q is now 7. P goes up by 1. P was 3. P goes up to 4. Print 4, 7. Q is 7. We come back. Is 7 less than 6? No. Stop this loop, but we come back. Okay, don't forget, we got to come back. P is currently 4. Right here, it's PQ. P is 4. Is 4 less than 6? Yes. Q starts over at 1. Okay, pay attention. Right now, it's 4, 1. Is 1 less than 6? Yes. Add them up, store them in Q. Q is now 5. Add 1 to P. P was 4. P is now 5. Print 5, 5 right here. Q is 5. Q checks again. We're in the inner loop here. 6, 5. 5 is definitely less than 6. Add them up. Q becomes 10. That's 5 plus 5. Add 1 to the 5 what P was. P is now 6. Print them. 6, 10. It's not done yet. Not done yet. We've got to make sure we go to completion. We come back. Since Q is currently 10, because it's PQ, is 10 less than 6? No. Hits here, comes back. Is it true that 6 is less than 6? No. The both knows. Loop finally ends. 6, 10 is the last one. We do one more, final one. So let's see. Number 19. We have a string computer. And we're going to be doing some substrings, so I already set up the substrings here, okay? 0, 1, 2, the lines between, like we did before, so we could figure out this substring. The length is 8, because we have 8 things. 1, 2, 3, 4, 5, 6, 7, 8. There's a string here that's empty, and the string gets concatenated in here based on a condition. So we are going through every single one in this string from 0 up to k less than the length. So when we get to the length, this is finished. So this is literally 8. Okay. So first thing is 0 comes in. Is 0 less than 8? Yes, it is. Is 0 mod 3 0? Yes, it is. So this thing gets to add on S, which is empty right now, the substring from 0 to 1. How do I know? Because k is 0. 0 to 1. 0 to 1 is a C. So currently right now, S becomes a C. Because S is C, you could already see the answer is starting off right. The S now, once we add on it, it's going to be adding on to the C. Okay, so S is currently C. It comes back because K++. It comes back. Is 1 less than it? It is. Is 1 mod 3 is 0? No. Remember what mod does. Remainder is 0 means it's divisible. 1 is not divisible by 3, so it adds an X. 2 plus not divisible by 3, so it adds an X. 3, like that. We keep going like that and until we finish writing out the whole thing. So let's run this and see what we get. CXXPXXEX. Let's take a quicker look and see why is it putting X's in these spots? Because these spots are not divisible by 3. When it is divisible by 3, it takes the actual letter. So for example, the first one was from 0 to 1 when K was 0. It took the C because 0 mod 3 is 0. The next time it was when we got to 3. 3 mod 3 is 0, so it took the P. 3 to 4. The next time it's divisible by 3 is when we get to 6. 6 is divisible by 3, so it's going to take 6 to 7. It takes the E. That's where we got the C, the P, and the E. Every other point, the else, we get an X. So that's where we got all these X's in here. Okay? And that's what S ends up with. These are hand tracing. Simply walk through the code, write down things if you have to. Go slowly, get your brain accustomed to thinking like this. And again, you could have seen the reason why nesting is not so good, because these are tougher, right? You should realize that nesting is... Imagine if I had another while loop inside here. That would be a nightmare. So when I said to you, don't nest more than 2, it was not for a joke, it was serious. 2-dimensional is tough enough. 3-dimensional is tougher and unnecessary, okay? Whenever you get a question that you need to hand trace, you're going to write things down. And you're going to take your time and walk through them. Okay, you can't rush. Take your time. That brings us to the end of pure hand tracing.